Hello, in this video we'll cover the basics of SMD soldering, and that stands for surface mount devices. And before we begin, I want to give a pep talk. I'm fairly new to SMD soldering, and I really wish I would have started earlier. I always thought that this was a type of soldering that was really for the soldering gurus and electronics geniuses, and it seemed sort of out of reach for some reason. And I realized that it's actually not that hard to do. There are some great tutorials online if you need some extra help with that. And I hope this tutorial will be helpful as well. And I've come to find, especially with the size of SMDs that I talk about in the book, it's really not that much different than soldering the through-hole components. For example, the ones in the mixer project that I talk about in the book. And so let's get started. To begin, a couple of things that you need for this is some isopropyl alcohol. I use a 99% to help to really clean the board. Also be using some tweezers, and you need a SMD size soldering tip. However, for this first component we're going to solder, I'll use just a regular standard size through-hole soldering tip, and then move to the smaller size for the other ones. And I'll demonstrate several of the different devices, how you might approach soldering those devices. In terms of the soldering lead, also for this first component, I'll be using the same lead as in the mixer project, and then we'll move to some lighter gauge soldering lead later in the video. Let's begin by giving the PCB a good clean with the isopropyl alcohol. And while I'm working, one of the things I really appreciate about SMDs is the ability to fit more components on a PCB. And in this case, I was able to design this PCB so that all the components fit on one side. And that there are some benefits to that. For example, if I were to want to manufacture a commercial project, this might have some advantages in terms of production cost. The first device that we're going to solder is what I find to be the most challenging, and that's a voltage regulator. And as with the mixer project, I'll be following along with the BOM, the bill of materials for this project. One of the first items is this 5 voltage surface mount regulator. And these are tricky because we want to, as much as we can, try to have good adherence to this bottom of the regulator to dissipate any heat. And one other thing that you'll need for this is flux. And so there are a couple of types of flux. I'm using a liquid variety, which I prefer. There's also flux paste that works well that you could consider. And I've heard also of a flux spray, which I don't have experience with. We've cleaned the board. Now I'll apply some flux to the area that we're going to work on. And that would be right in this region. Also, I wanted to mention that my soldering iron is set to about 370 degrees Celsius, which for me has tended to work out pretty well for a lot of different types of projects. A first step is to get my tweezers handy here and actually come at this from the other side. And one approach that I found to be helpful, and I learned this tip from an online tutorial, is to start by, we'll clean our tip. I'll apply some solder to the tip, and then we can just hold this in place and try to get things lined up nicely, and then just tack it in place. and I need a little more solder. There we go. Okay, so at this point it's actually a fairly skookum connection, and we can move to the other side and try to adhere that heat sink. And so one approach is just to apply the solder, and that flux is doing its job of transferring the heat. We'll just get it nice and hot, let it flow underneath as much as possible. Okay, I think we have a pretty nice adherence there. Some techniques that I've seen online, some individuals will apply a little solder to the pad underneath and then wick that up and to get some more solder underneath. So that's another strategy you might try. And that's a first SMD soldering. I will turn my iron off and let it cool down and switch the soldering tip and demonstrate a few of the other soldering techniques. Okay, so I have swapped out the through-hole tip for the soldering iron with a smaller 1.5 millimeter tip, and I'm using a Heiko 1.5 millimeter beveled tip, and for me that has been a choice that really works well and kind of fits my style of soldering, if you will. So that's what I'll be demonstrating in this video. So moving ahead, I wanted to mention that you may want to pick up a sample book, and these are books of, in this case, capacitors, surface mount capacitors of all different types of capacitance. There's also resistor books, and I have one of each, and they are not unduly expensive to purchase, and it's very helpful because you always have really any of the values that you need, and then you can just selectively fill any of the values that you run through by ordering a bulk of those particular values. So highly recommend this. One other thing I want to mention is all of the designs in my book, I use the 1206 size for surface mount, which is a fairly large size. So those are more reasonable to solder and don't require a soldering oven or anything like that, but yet you can still get a lot of components on a board should you want to do that. Moving back to the circuit board, I'll first show an example of the tip here, and we will apply some flux. And I wanted to start by demonstrating how you might approach soldering larger capacitors that are surface mount. So I'm going to apply some flux to these two, and again I'm working off of the bill of materials, and so C1 and C5 are both a 47 UF capacitor, which I have ready to go here. And an approach that I've found works pretty well is to apply some solder to that bevel, the soldering iron, then pick up the capacitor, position it, tack it in place, and I didn't have it down all the way, so I should have been pressing down more. That's all right, we can re-tack that, and I'll get a little more solder on my tip. One of the things I should mention is I use a magnifying glass that is lighted, that is lit, and I'm doing this without magnification. So There we go. So that's tacked in place. Then we can go ahead and solder the other. And then we'll loop back and make sure we have a good solder on this side. And you'll notice that that makes a very firm connection. Let's try the next one. I'll apply some solder. Remembering to press down. Tack that in place. Oops. And again, I think I'm a little more graceful when I'm using the magnifying glass. Okay. And then double check this one. And that's nice and solid. And of course I would zoom in with my magnifying glass to double check both of those solders, but they seem to be okay. Next, let's take a look at soldering an integrated circuit. And so I have an MCP 3202 that will go in integrated circuit 4, which is located right here. And of course you want to be careful about the orientation. There's a small dot right here that should correspond with the dot on the integrated circuit. All right, and I will clean the tip, apply some solder. And again, we're going to just tack that in place. I'll apply some flux, and I'm going to double check that number 4, yep, is the one that we're working on. And what I'll do is just use that small amount of solder just to tack that one lead, and that will hold it in place as we solder all of the others. Now for me, with my eyes, this is challenging to do without the magnifying glass, but you'll see with the flux that that solder just wants to go and be happy with being on the pad and the lead. Some people apply flux and just draw the iron over those pins, and that's okay too. But this is an approach that has worked out pretty well for me. So let's get the other side. You see it got a little bit there, and that's fine. And so again, I would check with the magnifying glass, but it looks like we don't have any soldering bridges or problems like that. And of course, it's a very solid connection as well. And let's also solder a resistor. And this project requires two 1K resistors on R1 and R17. I'm following the bill of materials. So I'm going to take out 2 resistors of that value and apply some flux. So I'll clean my tip, apply some solder that we can use to tack that in place on R1. This is probably the hardest part of the surface mount, is they're a little futzy to pick up. So I'm going to hold that in place, tack aside, okay, flip it around, solder the other side. And I know I've said it already, but I normally do this with magnifying glasses. So, all right. So you can see several components on there. And to show you an example of a completed project, this is the actual completed circuit PCB from the final project in the book. And of course, it's not of the quality that you would get in a commercially manufactured PCB, but in terms of connections and all of that, other than not being quite as pretty, this will do the exact same function. And to me, it's a very exciting part of circuit building. This idea of where you can design a circuit and bring it to fruition and solder it and have a useful electronic device. To me, that's very exciting. So don't hesitate to use the SMD components. They're not that hard to solder with a little practice. And you can have something fun and useful like your very own Eurorack synthesizer. So I hope you found that brief introduction helpful.